Here we go. We're drawing free-body diagrams. Apply the method described in the paragraph above to construct free-body diagrams for the situation described below. Book is at rest on a tabletop. Diagram the force acting in the book. This is probably the easiest one of the day. Weight force and normal force. Should the arrows be equal? They should. Balanced, right? Balanced forces. A girl is suspended motionless from a bar which hangs from the ceiling by 2 ropes. Diagram the force acting on the girl. Is it happening on Earth? Likely. Is there a surface? No, she's hanging by 2 ropes. Now, I know what the actual answer key shows. It actually shows 2 arrows up. F1 and F2. Now, they should be, if you add them together, they should be the same length as that, right? But I'm guessing that many of you just did that, right? Which is fine, as long as you realize that if they're in the same direction, that's okay. But if there's more than one and they're in different directions, then you do have to account for that, right? So it's not a terrible idea to get in the habit of putting one for every point of attachment, I guess you could say.
I didn't even know there's
2 ropes. An egg is free falling from a nest in a tree. Neglect air resistance. Diagram the forces acting on the egg as it falls. Is it happening on Earth? Yes. We got a weight force. Colin is right. That's it. Why is that it?
There's no air.
There's no air resistance. There's no normal force. There's no wind. There is literally nothing else applying a force. A flying squirrel is gliding, no wing flaps, from the tree to the ground at a constant velocity. Consider air resistance. Diagram the forces acting on the squirrel. FW seems to be a trend. And no, there's not an FN. It's a friction force. It's an air resistance force. And because it's at a constant velocity, that means that it should be equal. Okay? Now, people often say, well, I'm sure that the thing is going like sideways kind of, right? So yes, if you want, it doesn't say it, but you would probably have something like that, but then it wouldn't be traveling at a constant velocity, it would actually be slowing down, wouldn't it? Right? So yes, I understand your logic. I counter with, it says constant velocity. So maybe what I should do is change the question so it says the flying squirrel is dropping straight down or something. Maybe I should change it. Daniela, you need to focus. A rightward force is applied to a book in order to move it across the desk with a rightward acceleration. Consider friction. Neglect air. Weight force is across the desk. Fn. There's a rightward force and it's accelerating. So, and there is friction. So you got a small friction and you got a big FA. Getting the hang of it? Pretty easy, really, right? Rightward force applied to a book in order to move it across the desk at a constant velocity. So, in fact, it's going to be exactly the same, just the applied force is now the same as the air resistance. Or not air resistance, friction. Yeah. Well, do the up and downs have to match the left rights? Not necessarily, just each other, right? FF, exactly the same as this, right? We've got friction force, this is an applied force here. Pretty straightforward. College student rests a backpack on his shoulder. The pack is suspended motionless by 1 strap. Vertical forces. Yeah, FW down and the single FT up, and it's not going up or down, right? Skydiver descending with constant velocity. Consider air resistance. Weight force. Air resistance. Friction force. Constant velocity, they have to be balanced. These are pretty easy. At least, well, I've done them probably 60 times. So. Force applied to the right to drag a sled across loosely packed snow. That's code for? There is friction, exactly. Rightward acceleration. Diagram the forces acting on the sled. Weight force, normal force, friction, applied force. Why? The normal force in this case is equivalent to whatever the weight force is. If there's no other vertical forces, I think you're arguing that maybe there's a little bit of buoyant force. I don't.
It's not going to be less friction.
The frictional coefficient would be less, not the normal force.
You wouldn't draw.
No. The frictional coefficient, we're getting ahead of ourselves over here. The frictional coefficient is a measure of how rough the two surfaces are. So like rubber on asphalt would have a high coefficient, whereas like plastic on ice would have really low. But it doesn't reduce the normal force, it just reduces the friction. Okay, now this one often causes some discussion. Football is moving upwards towards its peak after having been booted by the punter. Neglect air resistance. It's happening on Earth. We play football on Earth. Says neglect air resistance. That is it. It's moving, but the arrows don't show movement. The arrows show forces. Has the football already been kicked? Is it in contact with the person's kicker's foot anymore? So he's not able to apply any more force. Doesn't matter how much leaning you do. You've seen that, right? There is no other forces. It doesn't matter that it's moving, right? The only thing that is forcing it now is gravity. It's already left his foot. There's nothing you can do. That one always causes some. What? Car is coasting to the right and slowing down. All four, says Colin. Okay, well, for sure, weight force and normal force, right? And there's going to be friction. No, it says he's coasting. Coasting doesn't mean braking. Coasting means foot off the gas.
That's still friction.
Is there an FA?
No. No, because we're not applying gas, he's not applying brake. I guess. So he's
Just slowing down, right? So I will accept either. If you argue that foot's off the gas, foot's off the brake, he's just slowing down, it's friction, right? Some people are smarty pants and say, well, even when your foot's not on the gas, there's a small amount of applied force. And that is true, right? Like if you ever got in a car and like put it in drive and kept your feet off both pedals, you're going to move forward, right? So that's true. But the overall net force would be to the left in this case. So maybe I lied. Maybe they aren't all super easy. Good thing I left the hard ones to the end. Okay, so we're going to solve some problems. I think I have 4 here. Let's make that a bit bigger so you can read that. You have the sheet in front of you, right? Okay, so basically you're going to have to take all the kinematic stuff that you already know, and we're doing the, like Shrek. Physics is like an onion. It's got a lot of levels. Layers, that's what I said. I saw Shrek this summer at Rainbow Stage. It was good. Okay, so we got a constant force acts on a 12 kilogram mass, changes its velocity from 4 meters per second to 18 in 3.5 seconds. What is the force? So we are solving for F. I have the mass is 12, changes its velocity from 4 to 18. So my initial is 4 and my final is 18. And my time is 3.5 seconds. And we are asked for what is the force. We're going to use AF is equal to question mark. So to solve this, we're going to end up finding right? VI and VF is 4 and 18. I call F net equals to MA, I call it the bridging formula because it bridges from dynamics to kinematics. So all of this stuff here is kinematics, right? So we're going to have to go from that through F net equals MA to find the force. Let's draw our picture first, right? Weight force, normal force, and we have a constant force. Is acts on. Well, that's just other words for applied, is it not? So we have an applied force. Is there any friction here? No. Do we need to concern ourselves with the weight force and the normal force? Are they balanced? They are. Do they contribute at all to the motion of this object? No. They're just sort of balanced, and they make sure that it doesn't go up or down, right? So basically they are useless. They don't do anything. So we're going to get rid of it. So this means that our net force, our total force is really equal to our applied force, right? My net force is my applied force, because the other two just balance out. F net is equal to FA. So I'm going to find F net, and that's going to be my applied force. How do I find F net? Mass times acceleration. Do I have the mass? I do. Do I have the acceleration? I do not. How do I get acceleration? A equals delta V over delta T. Do I have delta V? I can get it. Yeah, I can make it. Okay, so that's where we're going to start, right? A equals delta V over E equals MC squared, not A. Oh, but really I don't have, yeah, sorry. I snuck ahead there, didn't I? Sorry, yeah. Delta V, I know. Good thing you're using pencil. 18 minus 4. So the change in velocity is 14. So I got 14 over my time is 3.5. Now, just a reminder, how do we write solutions? We write the formula. Grayson. Excellent. We put the equal sign and we split them up, right? We line them up. We sort of put them in chunks. 14 over 3.5, I think, is 4 meters per second squared. F net is equal to MA. 12 times 4 is 48 newtons. Therefore, the applied force is 48 newtons. What do you think? Probably like 1 mark for the FBD, 1, 1, 1, 4 marks maybe? Don't forget your units.
So we have to draw a diagram or something.
I mean, this one's so simple, you probably don't even need the diagram. It helps.
How do you know when to draw the diagram?
Yeah.
If you gave it a mark.
Yeah, I would have to say include an FBD to give them.
But you just get in the habit of drawing it every day.
It's not a bad idea, yeah. I mean, eventually you'll get to the point where there's some that are so simple you just do it, right? But others you have to go, okay, let me see what's going on here, right? Okay, are we good? Yeah? That one's relatively straightforward.
Yeah.
Certainly a step up from what we did last unit, though, right? Okay. I don't think you have the picture here, right? Am I right? Okay. So a block is being pulled by a rope as shown. 25 newtons of force are being applied, and the friction force is 5 newtons. What is the acceleration? And if the force applied for 4 seconds, determine the velocity. So in fact, I've only started the FBD. But again, when you include the weight force and the normal force, do they do anything? Do they change anything with the question? They don't. They are balanced. They don't contribute to the motion at all. Okay? So, we are asked to find the acceleration. two formulas that you know that have acceleration in them. A equals delta V over delta T. Well, that's not, we don't have any of those, right? What about F net equals MA? We do not know the mass, do we? Do you have a number on yours? I hate it when there's a mistake like this. Yeah, but we need the mass, don't we? Can I just write it in? That's okay? 4 kilograms? The mass, a 4 kilogram block? No, I'll have to make sure that I've just missed not putting the number in. I probably said last semester, oh, I got to change that, and then I forgot.
Why don't you just change it now?
Then I got to take everything out, and I got to do it at the end. Remind me. Okay, so we're gonna first do F net is equal to MA. Oh, we don't know the F net, do we? Yeah. We don't know the F net, do we? Can I find it? Yeah. I know. F net is. Now, we haven't talked a lot about what F net is. F net is, ladies at the back, I need you to listen so I don't have to explain it to you individually. I'm talking to you. F net is the sum of all the forces. So we're going to add them all up. So it's the applied force plus the friction force. Do I need to worry about the up and down? No, we've already established that they aren't contributing anything, right? So I'm going to write F net is equal to my applied force, which is 25, and my friction force is 5. But because it's in the opposite direction, it's really minus 5. F net is equal to 20. Now that 20 goes over here, right? You see how things all line up nice? The mass is 4, and I conveniently pick 4 because I can do 20 divide by 4 in my head. Right? Divide by. You've got to be able to solve that without even thinking about the process. So I have an acceleration of 5. Meters per second squared. Acceleration, right?
It's -5 to this one.
Is it -5? No, because the F net is plus. It's moving to the right. So it's plus.
No, sorry, like from before. You called the friction force negative.
Yeah. Oh, because it's to the left. Yeah. Yeah. Okay. So my acceleration is that. So part B now. Here's the kinematics part. Here's the part where you get the redo on your test. Because is there going to be a question like this that it also appeared on the previous one? But it's your job to find it. If the force applied for 4 seconds, determine the velocity. The force applied for 4 seconds. Acceleration and time. A equals delta V over delta T. Acceleration time. I can find the change in velocity, can't I? So 5 is equal to delta V over 4 seconds, and oddly enough, I'm back to the number 20, but that's just, now it's 20 meters per second. Now to determine, I guess this is the final velocity, right? If the force applied for 4 seconds, determine the velocity. So they mean the final velocity, right? Did it tell us what the initial velocity was? It doesn't. So you have to assume that the VI is 0. So if the VI is 0 and it changes by 20, that means that the final velocity is 20. Could you figure out how far it goes? The distance. Good. Which one has distance in it? The one that has average velocity. Do we know the average? No, but can you find the average of 0 and 20 in your head? It's 10, right? V bar equals VI plus VF over 2, so it's 10, and it's for 4 seconds, so it's 10 times 4 seconds, it would go 40 meters. Ready to try one on your own? Oh, maybe this isn't the one I want you to do on your own.
Yeah, I don't get it.
Yeah. Okay, I need you to know, Colin, put it away. 100 kilogram crate is being pulled in 2 directions with different forces, 200 newtons south and 150 newtons east. If the friction force is 50, what would the acceleration be? Does this feel like it should have a picture? It does, doesn't it? Now, you need to be aware there's basically 2 categories of questions. There's ones where you're sort of standing beside it and you're looking at it side on. This one is talking about south and east. So the only way to get that viewpoint is exactly, Kat, you're looking down. You're like a drone version. Bird's eye view, they used to call it in the good old days. Drone's eye view. So you got south at 250, and you got east at 150. Oh, this feels like a, what kind of question? Vector. This feels like a vector question. How do we add them? Put them tip to tail. See how it just keeps coming back? Yeah, just keeps coming back. There's always a do-over in physics. Now, there is friction, and you're right, Kat. So which direction is friction? Well, which way is this thing going to move? It's going to move this way, right? Like if the forces are like that, it's going to move that way, which makes friction this way. Is that what you meant?
Yeah, so it moves up and to the left.
It's not moving, that's the direction of friction. Okay. Can we deal with friction as the first step, or what do you think the first step is going to have to be? Adding those two. Adding them two, and we're going to put them tip to tail. Have I conveniently made them perpendicular to each other? South and east. So that means we can use Pythagoras, right? 250. Okay. So here's my notation for this. I'm gonna do this, right? And I'm gonna say that the 250 and the 150, I'm gonna label them F1 and F2. And I'm gonna label the red one, I'm gonna label it FA. The well, it's like the overall applied force. Okay, does that work for you?
Yeah.
I mean, we're just talking labeling here, right? So the FA, the applied force, is the sum of the 150 and the 250. Is it 400?
No.
No. What do you got to do? Pythagoras. So FA squared is equal to F1 squared plus F2 squared. Can you feel your brain expanding with knowledge today?
Of course.
FA squared is equal to, that's going to be 150 squared plus 250 squared. And I feel the need for a calculator. You're going to tell me? Okay. Do I have one here? You know what? I usually just write FA equals. What's the FA at the bottom?
80,000.
No.
Oh, the square root of it?
Yeah.
291.
That sounds right. 291.5, I think, right? I've done these questions a lot. Newtons. So what did I do? I took 150 squared plus 250 squared, and then added them together, and then took the square root. And 291.5 is the correct answer. Should that answer be a little bit more than like the 150 and the 250? Yes, right? Yes, it's the hypotenuse. So my FA is my 291. Now we can go F net is equal to FA plus FF. And now we're going to deal with this friction. So the net force is going to be my 291.5, and I'm going to add negative 50. And I apologize for the scrunching. I'm going to add negative 50. And I get a net force of 241.5 newtons. But it's asking for the acceleration, exactly. So how do I get acceleration from F net? F net is equal to ma. Right. If the friction force is 50, right? Now, why is it negative? Is up and to the left negative? Really what we're doing here, folks, what we're really doing is we are assigning this direction to be positive and this direction to be negative. Because they're exactly opposite, we can do that. So 241.5 is equal to my mass, 100. A, we're going to divide both sides by 100. And we're going to get A is 2.4 meters per second squared.
Wait,
2.415.
how'd you get the mouse? Oh, wait.
It's in the question. Am I done?
I don't know, I hope you were.
No, the answer is no.
Because usually when teachers say, are you done? You're not.
You already copied.
You're right. But you have forgotten that acceleration is committing crimes with both magnitude and direction. It is a vector, which means you need an angle. I need a direction. Now the rule of thumb is well, it's going to be south and east. The rule of thumb is if the words south, east, north, or west appear in the question, 99.9% chance they're going to have to appear in the answer. Okay? And not just southeast. So, you actually have to do this. Oh yeah. 150, 250. Oh, just you wait, Talia. You know what? After I'm done here, I'm going to show you the grade 12 stuff I showed yesterday. No?
I need time to do this.
Fair enough. I don't want to scare you.
No.
You can all do it. You'll be amazed at the, what does Shrek have? Layers that you're going to add to your brain. Yeah, he does. He's like an onion. Oh, he's like a trifle. Parfait. Trifle's like a dessert. It's got like different layers. Pudding and fruit. Kind of like, it's like a big parfait. Okay, so theta is going to equal inverse tan, opposite over adjacent, 250 over 150. I think it's 32 degrees. My memory tells me 32 degrees. We're going to see.
Okay, this question is wrong.
What would the acceleration be in your thinking?
No, it goes on, 59.
59 degrees.
59 degrees. Now that's going to be, now how do you know which direction? So that's the 150 is east, and that's first, right? So it's going to be east, east 59 south.
Why can't I? Do you sell?
1, 2, 3, 4, 5. No, you can't do just southeast because just southeast means 45.
So then you go back to your answer. Oh no, never mind. You just.
Whew. Better towel off. You know what? I know the last one's easier. I set it up that way.
What's the next one you're on? Like,
I would like you to try this. I think I've given you enough space. I'll tell you this. It's 2 steps. Draw a line down the middle of the answer. Because you're going to do your answer on the left, and I'm going to show you my answer on the right. Hopefully they're the same. But you've got lots of room, so I want you to try it. I'm going to go do attendance, and then I'm going to show you this answer. Because I want to give you a little time to work, I'm going to do this here. Does it help to write the formula here? I hope you're slowly learning that. Well, actually, I hope you're learning it fast, but... Okay, so we need to find the FA. What was your first step that you did? What do we know? We know the mass and the acceleration, so that gives us the F net, right? So F net is equal to 1,800 times 1.75. 3150, am I right?
Yep.
Colin, put it away and watch. Okay, so the net force is 3150. Right? I'm guessing many of you got that. Okay. No? Logan, get rid of the earbud. Okay, well that's the net force, right? Now, F net is equal to FA plus FF, and I'm thinking maybe a good number of you wrote that. Next. What's the F net? Do we know it?
yes.
3150. We need to solve for FA. Oh, this is looking real good. We need to solve for FA. And what's my friction force?
Negative.
Minus 250. And how do we get rid of minus 250? It's not a double negative. It's FA. Really what it is FA plus minus 250. All right, so you're going to add 250 to both sides, and your applied force is going to be 3,400 newtons. Easy, Riley. Now, the most common mistake, the one that all kids do, is they get all excited. They go, oh, I just subtract friction, I'm good, I'm done. Woo, get done. Get as fast as I can.
Oh, there's like
That's enviable.
Yeah. Okay? By writing the formula, and I do this very question at this very stage right now to show you that writing the formulas is 100% necessary, because that's how easy it is to screw it up. Because people think, oh, just subtract the friction, we're done, right? That's not the way it works. You've got to be careful. You're actually adding friction. And if you think about it, if you stop and think, Colin, I need about 2 more minutes. If you stop and think about it, right? If the applied force is 34 and you lose 250 for friction, then you have left 3150 to do the accelerating, right? Like if you need 3150 to accelerate and there's friction, then you need even more than 3150, right? So you don't subtract. You in fact add the friction. But writing the formula helps. I hope that you have come to that realization. Okay. My turn to be quiet. You have problem set 1, and oddly enough, the backside is known as problem set 2. Colin, 31 seconds. Okay? There are answers, and there is a QR code for, I think the front gets you to the solution. I think there's all one big giant set of solutions. There are some that you can't do yet. Okay? Anything that's at an angle, you're probably going to have a tough time. Like number 7 and 8 on the front page, you're going to have a tough time with. Okay? And at some point, if I ever get a whole pile of free time, I'll start separating. But that day will come after retirement. Sure. So you have the rest of the period to work. I strongly urge you, you've just learned something, practice it. Don't just pack up and get on the Twitter feed for the next 12 minutes, because you won't have learned anything. Practice it. Take it home. Practice. We'll expand. We'll probably do some more sample ones on Monday.